Hello, this is take 4. This is the Thévenin experiment, where we create a Thévenin equivalent circuit from a quote-unquote normal circuit, or one that involves multiple power supplies and multiple resistances. Sometimes different types of power supply, so current and voltage power supplies. But unfortunately, due to COVID-19 in the year 2020, I should mention this is December 12th, 2020. So we're at the end of the year, thankfully. So this is it. We have these two right here. One of these is a 2.2k ohm resistor. The other is 3.3k. That's 1,000. And this is a 1,000 ohm load I have currently hooked up with the banana plugs. See? And so the reason why I say I bring up COVID, because that's kind of affecting everything. We are now studying from home, experimenting from home, and working from home for most of us. I only have the one power supply. Normally you'd have 2 or 3, and I did have some 9-volt batteries, but they are there's too much difference between the two. They're not identical. There's close to a 10%, anywhere from 6 to 10% difference, so that already can skew my numbers. I can't create a Thévenin equivalent without having identical batteries, and I need to get this experiment done. So, just like so many others. So yeah, for most cases you would have multiple power supplies. Maybe 2 variable power supplies would do you justice, do you good for this experiment. Yeah, so this is the first one, and I can just keep this running. I don't even need to pause. We'll just remove the 2. Goes to 0. Now we insert a 5.5k resistor here. Right. There we go. All right. 5.5. You can tell it's 5.5 by that green, blue, red, and I think that's gold. Could be copper. And as you see, we have about a 0.02 to 0.03 difference, depending on the flow of electricity, our charge carriers. So that's our voltage. From this voltage, we can calculate our current that is coming through, because the total voltage of the power supply is approximately 18 volts. Could be a little more, could be a little less. It does fluctuate, but this is what we're finding at the load, and that's what's important. The applied load will act the same. I would say it's the same, considering it's within 1% between the two. So that makes me happy.